Hi everyone, welcome back to my channel, Doc at Home, where I try and demystify original published scientific research on selected topics for the benefit and awareness of education and for those that are interested. If you have any topics that you'd like me to research, drop me a comment and I'll see what I can do. To the new viewers who joined, check out my other content on my channel, and if it's for you, please like, share and subscribe. Today I'm summarizing a published study on circadian rhythm and blood pressure regulation in diabetic mice and their feeding states. So let's start. Today's research short is from Tao et al., who did a study in 2021 called Time-Restricted Feeding Protects Blood Pressure Circadian Rhythm in Diabetic Mice. Full text is available from the Proceedings of the National Academy of Sciences, PNAS. Some of the key concepts discussed in this paper includes time-restricted feeding, blood pressure circadian rhythm, non-dipping blood pressure, type 2 diabetes, sympathetic nervous system, meal timing, to name a few. Further research on time-restricted eating. I found two more studies since this paper in 2021 was published. The first was from the same first author, Tianfei Hao, called The Role of Sympathetic Pathway in Late Phase Time-Restricted Feeding Induced Blood Pressure Circadian Rhythm Alteration. That's a mouthful. That was published in 2022, and it's a follow-up to the 2021 paper, which I'm talking about today. And I also found a preprint that was dated July 2024 in the National Library of Medicine by the same research group, and that is called Annexonate Administration Time Determines the Effects on Blood Pressure Dipping in Diabetic Mice via Modulation of Food Intake and Sympathetic Activity. So what a preprint actually means, it's just the study has not been peer-reviewed for publication yet, but it is part of the National Library of Medicine's pilot to include preprints of studies that they funded on their website, and I'm sure once the study is actually peer-reviewed and published, it will then be a full publication. It will be in full publication on the on the website. Introduction. Understanding blood pressure and diabetes. Okay, so let's just do a few concepts so we're all on the same page. Blood pressure is the force of blood pushing against the walls of your arteries. It naturally rises and falls in a daily cycle called the circadian rhythm. The higher the force, the higher your blood pressure. The lower the force, the lower your blood pressure. And a normal blood pressure, you can all research this, is 120/80. For anyone who has high blood pressure, that number will be higher, but the lower the number, the better. And in diabetics, they normally medicated, so their ranges would normally be anything below 140/90. But if the individual is over 80 years old, we're looking at a number of 150/90. And for those who are diabetics with kidney disease, we're looking at medicating it to get it to a level of 130/80. And that information is taken from the Diabetes UK website. Okay, let's move on. Circadian rhythm. It's a 24-hour internal clock in your body that regulates various functions, including sleep and blood pressure, and that's controlled in the brain. Non-dipping blood pressure. Normally blood pressure drops at night when you sleep, and that's called dipping. In some people, especially those with diabetes, this dip doesn't happen. That's called non-dipping, and this is risky because it increases the chances of cardiovascular problems. Sympathetic nervous system. The part of the nervous system that controls fight or flight responses by increasing your heart rate and your blood pressure when you are stressed and or active. When overactive, it can prevent your blood pressure from dropping. And lastly, diabetes, We all know what it is. High blood sugar often leads to complications like high blood pressure. It's called hypertension. So remember, in type 2 diabetes, there is an elevated risk of hypertension, but the opposite is also true. If you have high blood pressure, it also puts you at risk of developing type 2 diabetes. It's part of the metabolic syndrome, which I talked about in one of my previous videos, the one on the deep dive on my blood results, in the context of insulin resistance, diabetes, and pre-diabetes. So check that out on my channel as well. Back to the research paper. What was the study background and objectives of the paper that I'm reviewing today? Well, the problem, many people with diabetes have non-dipping blood pressure. That means blood pressure that doesn't drop overnight, which puts them at a higher risk of heart disease and strokes. What's the current knowledge? So scientists know that that what and how much we eat affects our health, but they are now learning that when we eat is just as important. What's the objective of the study? The study explores whether time-restricted feeding, that means eating during specific parts of the day, can help restore normal blood pressure rhythms in diabetic mice. And the key question, can adjusting meal timings improve blood pressure control in diabetes? A quick look at the methodology. The study was done using diabetic mice, which are a common model for type 2 diabetes research. The feeding patterns were, there was two groups, the ad libitum feeding and the time-restricted feeding group. In the ad libitum feeding group, the mice could eat whenever they wanted, almost like all-you-can-eat buffet style eating. In the time-restricted feeding, mice could only eat during an 8 or a 12-hour period in the active time. That's during nighttime, because mice are nocturnal. Blood pressure was measured continuously for 24 hours to track the circadian rhythms and determine if blood pressure dipped at night. And the sympathetic nervous system, they also measured activity in the SNS, which controls the fight or flight response and can be raised when overactive. Okay, in terms of results, I've got figure 1 and figure 2. For those that are interested in crunching the numbers, looking at the numbers, likes graphs and statistics, the research paper is open access, so you'd be able to have access to actually look at the results in a bit more detail. I just wanted to pop some of this on the screen, but I will explain in my next slide one or two sections of the results. Let me just continue with the results. I just pulled this figure 3, from the research paper, and it says time-restricted feeding restores blood pressure dipping in non-dipping diabetic mice. And the blood pressure was monitored by telemetry. So what that actually means is, through all the studies they've done in this paper, they found that if you restrict diabetic mice to certain feeding windows, 8 hours or 12 hours, you'll find that their blood pressure will dip according to the circadian rhythm, compared to when mice were allowed to eat whenever they wanted to eat, and their blood pressure would not dip according to the circadian rhythm for the blood pressure regulation. But just to look at two more examples of how beneficial time-restricted feeding is in these diabetic mice compared to the control group. If I just pull out graph H, you can see the daily food intake in grams for the diabetic mice who are all you can eat compared to diabetic mice time restricted feeding. And if you basically look there's a daily food intake decrease for the diabetic mice who were restricted in their feeding. So they actually ate less because they were restricted. They were still offered the same amount of calories to eat, but over the period of time they actually ate less than the mice who were allowed to just eat at will. The other one I want to pull out is I, graph I. And because the diabetic mice on the restricted feeding pattern ate less, surprise, surprise, their body weight went down. So on average, they weighed less at the end of the series of experiments compared to the diabetic mice who actually were not restricted to certain feeding windows. And the key message for that is both food intake and body weight was significantly reduced in diabetic mice on a time-restricted feeding compared to diabetic mice who were basically eating ad libitum. And this also just shows you how the blood pressure regulation through circadian rhythm changed because of using time-restricted feeding in the experimental group, which is the diabetic mice with the time-restricted feeding. On the left of this graph G, if I just can highlight, so this section here is basically the mice that could eat whenever they wanted to, and this grouping here is the diabetic mice who were time restricted in their feeding. And you can clearly see that's a bit more level, isn't it? There is ups and downs, but you can really see the up and down in the blood pressure, the mean arterial pressure throughout for the time restricted feeding mice. So that would mean that there is dipping. So these mice were also diabetic, but their blood pressure actually dipped. And this is quite encouraging to see that just by changing how, shall I say, when the mice were actually allowed to eat, it made their non-dipping blood pressure become dipping blood pressure. So it followed the circadian rhythm quite nicely. I think that's basically the crux of the outcome of the study. Like I said, for those who are really into statistics, number crushing, and the science behind it all, you can have a look at the research paper, and all the information would be there for you to actually peruse. I just want to quickly just say the statistical analysis that was used to crunch all the numbers. Various statistical tests were used to analyze the data, including the two-way ANOVA, t-tests, and one-way ANOVA. And the results are expressed as a mean plus minus a standard error, SEM. And the significance levels for this study, there was 3 significance levels that was used. It was a p value of under 5%, a p value under 1%, and a p value under 0.1%. And on some of the graphs, you'll see 1 asterisk, or you'll see 2 or 3. So for instance, there'll be 2 there, and sometimes you'll see NS, there's 3 there, and that just corresponds to how significant that result is according to the hypotheses that the researchers set up when they started the experiment. So in statistical analysis, the p-value indicates the probability that the observed results that the researchers saw occurred by chance. So which means p-values suggest stronger evidence against a null hypothesis, meaning the results are more statistically significant. So if your p-value is 5%, i.e. 0.05, it indicates there is less than 5% probability that the results are due to chance. And that's normally the level that we use in research. But if you have a p-value of 1%, 0.01, that indicates a stronger significance, i.e. there is less than 0.1 98% probability that the results are due to chance and not due to experimental design. And in this study, we found that most of the results were less than 0.05, 0.01, but we even had results that were so significant, the value was 0.1%, i.e. the p-value was 0.001, and that indicates a very strong significance with greater significance. So yeah, I just wanted to go into the statistics a little bit. If you don't understand any of that, just ignore what I just said in the last 2-3 minutes. But anyway, this is just the results, and now I'll move on to the next slide. Okay, now we've done all that statistical talk. What does the results actually mean? So firstly, what it means is blood pressure that doesn't dip, the non-dipping blood pressure in diabetic mice. So the mice that ate whenever they wanted had a blood pressure that stayed high at night. It did not dip. Secondly, the time-restricted feeding that was done by the diabetic mice on that part of the experimental setup, they had a normal blood pressure rhythm. So the mice that were on the time-restricted feeding schedule had a blood pressure that dipped normally at night. So the blood pressure followed the circadian rhythm of it is higher in the mornings and during the day, and at night and overnight it dips naturally. Okay, so this was also seen in both the 8-hour feeding window and the 12-hour feeding window for the diabetic mice on the time-restricted feeding. And in both these separate subgroups, there was no cutting of calories. And why it works. So time-restricted feeding reduced the activity of the sympathetic nervous system during the mice's rest period, allowing the blood pressure to lower naturally at night. So just to conclude, the timing of meals can play an important role in regulating blood pressure, especially for people with type 2 diabetes. The research suggests that time-restricted eating could be a simple, non-pharmacological method to help people with diabetes lower their risk of diabetic complications as well as heart disease by restoring healthy blood pressure rhythms. And while these findings are in mice, they open up an exciting possibility for future human studies and personalized health strategies. More research is needed to confirm the results that are seen in the mouse models and how it applies to humans, but the early signs are encouraging. In closing, I'm just sharing the reference for the research paper. And I'm also going to share a few other links. There are videos on YouTube, which I think would be beneficial to watch if you're interested. So it's just all about the link between diabetes and hypertension, everything you need to know about the circadian rhythm, how to harness the circadian rhythm for better hypertension management if you're at risk or are hypertensive. And because we talked a lot about time-restricted feeding in the diabetic mice in this study, I put in another link for time-restricted feeding versus intermittent fasting for those who've heard about that and what's the health benefits. And just please note, my talk is for awareness, education, information sharing, and to start conversations. It's not meant to be medical advice. So if you have any concerns, please go speak to your healthcare team, your doctor, your nutritionist. And if there is any particular questions about what I've covered in this particular talk, just drop me a comment. And if you enjoyed the video, please like, please share, please subscribe. And that's it for now. And until we chat again, thank you for joining me.